Good morning and welcome everyone. My name is Saurabh and I'm the VP of software here at Violin. And before we basically dive into the details of the Symphony, which is our management software and the stretch cluster, wanted to start with the overview of our Concerto operating system, which basically powers all of the different flavors of the Violin Flash storage platform. And as Saeed mentioned before, basically it's like one integrated architecture which basically provides you all the comprehensive data services and data protection mechanisms, which basically can power any tier 1 data center. So looking like the different modules over here, basically like the heart of the system is built around a very powerful virtualization engine, which basically abstracts the physical storage out of the layer. And that basically gives us the capabilities to basically grow the LUNs or the containers runtime, and also be able to give us the scale-up architecture where you can add more shelves and arrays behind the 7700 and grow it seamlessly without any disruption to the IOs and without any disruption to the application from the growth standpoint. So from the virtualization engine, basically what emerges, like we support various kind of LUNs or containers, whatever you want to call it. And primarily we support three major types, which basically are performance oriented or the thick LUNs. You can like do the over provisioned thin LUNs, and then the space optimized dedupe LUNs. So all of those things are coming from the virtualization engine as the containers. And then what we have done basically is that the storage services are built around those containers. So you get a similar data protection schema irrespective of what kind of containers you are using, and that kind of gives you the efficiencies in terms of the architecture, the scalability, and also basically provides you the simple mechanism from the administrative and the management standpoint, is that whether it is a thick or a thin or a dedupe, basically the data services in terms of the snapshot, replication, cloning, mirroring, stretch cluster, they basically work all the way the same way across the system. And that
can you make a change once you've decided? If you create like a thick container, for example, can you change that to thin at a later time?
Yeah, so today what we basically support is the online conversion of the space optimized or a dedupe container to be a thin container. So depending upon, let's say like you start out that, okay, I'm gonna look into the space optimized, but for whatever reason, if you are not happy with the performance or the latency which you are getting out of the space optimized container, you can like convert online to be a thin container, and then you can get the performance and the latency, which basically will be much more faster.
And can they be combined? Can you have like thin and dedupe together, for example?
Yes, so basically we do support the combination of the mixed container. So we have the concept of basically what we call the grouping of the containers. So let's say like if you are running your OLTP application and or some other application where you say that, okay, my particular containers can be more benefit by doing the deduplication over there versus some of the container where basically maybe you are doing your log data, or maybe the data which you don't care about, which will be thrown away after the processing has been done. Then you can like combine the dedupe and the thin containers together, and then still you can run the services on top of it in a generic fashion. So when you talk about the snap, the mix and combination will be snapped at the same time, will be replicated at the same time. So the group notion is always maintained in terms from the data services standpoint.
You mentioned that you can add additional shelves into these as well. Do you have the ability to, say, for example, by policy, decide on those containers as what level of high availability they have? So, for example, ensuring that you can mirror across shelves, the loss of a shelf doesn't then lead to loss of data? Yeah.
So basically, yes, if you have the multiple shelves, that is one of the advantage you get. So based on the container and depending upon what kind of data protection you are looking for the particular container, you can like choose to mirror it across multiple shelves, so that even if the shelf goes down, your data is going to be served from the different shelf.
And then as you add additional shelves, does that automatically rebalance data across to even out performance across the shelves?
Yeah,
is that more of a manual process?
Yeah, so today that is like more of a manual process. So basically we can use the mirroring or the replication within the box to balance out the data. That is like something which we are like kind of looking from the roadmap and the future perspective.
Is it just mirroring, or could you have like a RAID 5 stripe across 3 different shelves, for example?
So the array by itself is a fully contained unit, in a way that basically at the lower level, basically the V rates, what Saeed mentioned, they are contained within the array itself. So basically you have the level of protection that if a single VIM or a module goes down, then the rate basically kind of protects from that perspective. The data protection services which we provide in terms of the cloning or the mirroring or the replication, that basically takes care of if the whole array goes down, then how you protect yourself from the array failure. So just like covering the boxes over here, as I said, like in the middle is like most of our virtualization engine and the services which are running on the container basis. We have the capabilities of doing inline deduplication and compression. And basically the block on the right hand side kind of shows the modules and the stuff what we do over here. It all gets tied together with the management services, where basically we are able to provide the high availability, the inter-process communication. You talk about your manageability systems in terms of CLIs, logging, REST APIs. Everything is built in on the manageability side of the stuff. And on the top, basically, we have the user interface, which basically we're going to get a deep dive into next. And that basically is a single point of glass management system, which basically brings all of these three elements together to give you the experience from the array standpoint.
What's the difference on write performance on the dedupe section versus the non-dedupe section?
Yeah, so on the performance array, on the performance containers, we basically see about 1.1 million IOPS sub millisecond latency. On the dedupe side, currently we are like doing around 250K IOPS with the sub millisecond latency.
So the interesting thing, Curtis, is I think Violin, the only ones I've ever seen publish figures for before and after. Everybody else just says, oh, we're brilliant, but they don't show what the dedupe numbers are. So I think they've actually been quite honest in saying that.
Although if you look at like a SolidFire or an Extreme IO, the dedupe is so central to the way they store data.
Yeah, you can't necessarily turn it off.
That
absolutely.
Non-dedupe just doesn't make any sense.
Yeah. So that is also like, and again, you know, a little bit of a philosophical approach in that ways that if you look from the data center or the storage world, they are like kind of dealing with all different kind of applications, starting from your legacy old OLTP applications versus what the new applications which are coming out, which are more smarter. They want to take control over on their own data set in terms of like how they want to manage the multiple copies and all that stuff. So that's how the system kind of like gives you the flexibility. It does not enforces you to use the features which are provided by the array forcefully on the all workloads and all kind of applications. So if you are running a OLTP coming from the traditional world, you can like offload it to the array to do your snapshot replications and all those things. Versus if an application is smart enough, they want to place the data, you can easily turn off that, okay, I just need a storage and application is going to take care of maintaining the multiple copies, so you don't need the snap or the replication. So we have that flexibility to align to what the application wants to do rather than enforcing that this is what my storage is capable of doing, so you have to use the features in that regards.
So what's, I just want to make sure I understood your answer. I think I did, but from a performance standpoint. So it sounds like you're saying that you can do the same performance from a, like, assuming if we were at 250,000 IOPS, your performance on the dedupe side is the same as the performance on the non-dedupe.
No. So what I'm saying is that basically non-dedupe container basically is capable of giving you much better performance and lower latencies, which basically is around 1.1 million IOPS with sub-millisecond latencies.
Right, but then it's an interesting way to say it. You're saying you can do a million like I'm not thinking about the million IOPS, I'm just thinking about my single IOP or my
just the latency.
10,000 IOPS. I'm thinking about the latency, right? So, especially since that's the thing that you push, right? So, if what I'm hearing you say is you can, your answer in both situations ended up with sub-millisecond latency. You said you could do a million IOPS with sub-millisecond latency or 250,000 IOPS with sub-millisecond latency. So it sounds like the second part of the answer is the same for both. That's what I was saying.
Yeah, Curtis, remember the dedupe process happens after the acknowledgement, so it doesn't show up in the latency.
Is that why?
Yeah, because you receive the data, you write it to a buffer, in this case NAND, usually NVRAM, and you act. then you generate the hash, and so it doesn't affect how long it is to the ACK.
And also, like just the comment on the the definition of inline or post process.
We're arguing that offline.
Yeah. Okay. No, just like my sentiments over there is again, it's like kind of a debatable item in terms of like how you portray and perceive the things. But like the post processing or the inline, so the dedupe penalties in terms of like being able to generate the hash, do a lookup, and then eventually store the data. The penalties itself, like basically, are so heavy that they don't allow any application or any vendor to give you those kind of latencies which are looked in over here. So everybody pretty much have a landing zone, whether it could be a DRAM or it could be a NAND, which is in our case. But what kind of like goes into the definition of what is post process versus what is inline is like you have a fixed boundary of how much the data which you are going to land in that space before basically you are going to start throttle it up so that your back-end dedupe pipeline is working efficiently in over there. Typically, the post process is going to be that irrespective of how much I'm ingesting, I'm just going to keep on ingesting, and then there is going to be a offload process which basically is going to crunch the numbers and then free up the space.
Yeah, and the problem with post-processing in primary storage is you can't do capacity planning.
Yeah, so that's where...
If it dedupes overnight,
yeah, so
then
exactly.
you just
yeah.
have no idea how much free
Yeah.
space you really have at any given point
Yeah.
in time.
So that's why, like, basically, it's like, again, the inline is in a way that you will never cross those bounds, and we can always give you that boundary condition that when we eventually store in our repository, it will be deduped, and you are not running any after processes after the data has been ingested.
Yeah, and I think this comes back to really three things, right? You want your dedupe engine to be fast because you're buying flash, not disk, right? So you want the performance of flash. You want it to be easy so you don't have to worry about the capacity implementation. So it is real time or near real time. And we've seen implementations that even go back, even on all flash arrays, shipping products today, go back and reanalyze if they can create efficiency. And the third thing is you don't want it to wear your flash out unnecessarily, which is another problem of post-dedupe, where you're obviously doing a lot more unnecessary writes to your flash layer. So if you can do all three, I think that is kind of what customers are looking for as part of deploying flash with inline dedupe and compression.